Hey everybody, I'm Mike Thompson at the Epic Flight Academy. Thanks for being here and welcome to the Private Pilot Ground School. I know some of you have been watching a series of these videos and you're wondering, hey, what's next? What's next? Airspace. Now, when we study airspace, remember, please, you must be following the online Epic course. These videos are the second part of that, and they parallel that course. And then thirdly, and just as important, is you're going to want to review all of this material and content with your flight instructor individually, one-on-one. So let's get started. What about airspace? Have you ever sat outside, maybe on a nice blue sky day, a picnic table, maybe you're just looking up and you're seeing the birds and you're seeing planes fly over and you're wondering, do we just fly anywhere we want, anytime we want, however we want? Well, yes and no. The birds certainly do. And as a pilot, I might do that if I had to in an emergency. But during normal aviation operations, pilots are flying within what we call airspace. Airspace is defined in the sky three-dimensionally in our mind and recorded on charts. Now, as we study airspace, one of the difficult things for us to do as pilots is to visualize this airspace three-dimensionally. That's why it's important to understand these charts and what it looks like on the chart, and then kind of start to, visualize it as we fly through it. So that's why it's important to start first with charts. It's important to understand that there are a lot of different types of aviation charts. And you're going to study most or all of these as you proceed through your private instrument and commercial training. But as a private pilot, one of the charts that we use the most is called the VFR Sectional Chart. A second chart that we use a lot is a VFR Terminal Chart. And the third one is commonly referred to as a WAC chart. Now, that doesn't mean I went wacko. That's WAC, World Aeronautical Chart. So why do we have different charts? Why do I need to look at all three of these? Why wouldn't one suffice? Well, when we're flying visually under visual flight rules, the short answer to that question is just scale. The charts are sized up on a larger scale or sized down on a smaller scale. So let's start from the largest scale and work down. The largest scale is the WAC chart, or the WAC, World Aeronautical Chart. The scale on this chart is 1 inch is 14 nautical miles. So it's like a bigger view. On one chart, we're going to have a larger geographical area. And then the next one down there is called the VFR Sectional Chart. And that's exactly what it says it is. It's just certain sections of the country. And the scale here is 1 inch to 7 nautical miles. So you see, we just cut that geographical area in half. It's like zooming in. And then the last one is the VFR Terminal Area Chart, and here we have 1 inch on that chart equal to 4 nautical miles. So almost half again. Not quite half, but almost half again. So these charts are kind of scaling down and zooming in. All right? Now, as we take a look at these charts, let's take a little bit closer look at any one of the three of them, but we're going to start with the sectional chart. Now, the new Smyrna Beach Airport is on what we call the Jacksonville Sectional Chart. So if you have one handy, you might want to look at it, or certainly when you review this with your flight instructor, you will. When you open this chart up, I want you to notice that there's a north side to the chart and a south side to the chart. Now, whichever side we're looking at makes no difference. We're going to see a multitude of lines. One of the confusing things about cartography, what's cartography? Hey, what's cartography? Cartography is the art and science of creating and drawing these charts. So one of the challenging things is to get all of this information and all of these different lines onto a chart where a typical person, like a pilot, could still read it and make sense of it. When you first look at it, you might think, oh my goodness, what a bumble jumble of lines and symbols. If we work at it piece by piece and we start to take it apart, that bumble jumble will soon start to make sense. The first line I want you to look at with your flight instructor is the lines of latitude and longitude. Here we see latitude shown on your left and longitude shown on your right. Latitude is shown in red in the southern hemisphere and blue in the northern hemisphere. Now, this is just in our example, not on the actual charts. These lines run horizontally or laterally east and west. 0 degrees latitude is at the equator, and 90 degrees latitude is at the geographic north or south pole. Not the magnetic pole, that is magnetic north and south. 90 degrees of latitude is at the geographic north or south pole. Now notice how the circumference of the lines of latitude gets smaller and smaller as we get closer and closer to the north or south pole. On your right, shown in red are lines of longitude in the western hemisphere, and shown in blue are lines of longitude in the eastern hemisphere. These lines run vertically, north or south. And again, they converge at the geographic north or south pole. 0 degrees of longitude is at the prime meridian. Lines of longitude are measured 180 degrees to the west and 180 degrees to the east from the prime meridian. Together, west and east longitude adds up to 360 degrees of longitude, coming full circle around the planet. Notice how the circumference of the lines of longitude stay the same as we move around the planet. Now, this will be important in just a moment. So, what is our reference point for the prime meridian or 0 latitude? You might notice that it looks like the prime meridian runs through London, England. Well, precisely, the prime meridian runs through Greenwich, England. Now, here's a little bit of navigation history for you. A carpenter from Greenwich by the name of John Harrison invented a seagoing chronometer. In other words, a clock that kept accurate time on a pitching and rolling ship. His clock allowed for much easier and far more accurate calculation of longitude. The prime meridian runs through Greenwich in his honor. Time zones are also based off of the prime meridian. So we have terms like Greenwich Mean Time or GMT, also known as UTC or Universal Time Coordinated. Now, let's take a look at lines of latitude and longitude on this sectional chart excerpt that you see here. As you examine these lines of latitude and longitude, notice each degree of latitude and each degree of longitude is divided up into 60. Each of these small tick marks is referred to as a minute of latitude or a minute of longitude. Now, I want you to practice with your CFI and pick a point on the chart, such as, say, your home airport, and identify it with specific latitude and longitude numbers. First, identify if the latitude is north or south, and if the longitude is east or west. And then second, identify your location with both degrees and minutes. Practice locating various specific points and determining their specific latitude and longitude in both degrees and minutes. Now, here's a question. What is a knot? As in a knot of speed. Well, a knot of speed is based upon nautical miles. So first, we must identify what is a nautical mile. A nautical mile is 1 minute of longitude. Remember, as discussed earlier, a minute of latitude will get smaller and smaller as we move north or south because the circumference of a line of latitude gets smaller as we move north or south. So a nautical mile cannot be a minute of latitude because that would not be consistent. However, as you recall, a minute of longitude stays the same because the circumference of a line of longitude stays the same as we move around the globe. So a nautical mile will be consistent as a minute of longitude. Now, back to a knot. If I were to move 1 full minute of longitude in 1 hour's time, I would be traveling at 1 knot of speed. Aha! Now this is making better sense. If I were to move 1 full minute of longitude in 1 minute of time, I would be traveling at 60 knots. Now notice on this excerpt from a sectional chart that inside each box created by lines of latitude and longitude, there is a bold 2-digit number. For example, 33 or 47. This number is known as an MEF, or maximum elevation figure. These MEFs are shown in each square defined by latitude and longitude, and they will show either the highest elevation of any man-made obstacle within that square plus 100 feet, or the MEF may be the highest elevation of any geographic obstacle within that square plus 200 feet. The MEF figures are shown in hundreds of feet, so 33 would be 3,300 and 47 would be 4,700. MEFs are MSL altitudes, so they can be read right off of your altimeter. Now, as you study these sectional charts, always remember to begin with the chart legend, such as shown here. Study this legend and find each of the legend items on the chart. This will help you immensely in understanding and interpreting the chart. There is so much information that we could show on a chart. There is no way for a cartographer to include all the information that we want to convey on the chart itself. The chart would get far too crowded and difficult to read. So, the information is provided on a chart supplement. And you can see the cover of a chart supplement shown here. Now, in the same way that you begin with the legend when looking at a chart, begin with the table of contents when looking at the chart supplement. Well, folks, that wraps up our introduction to charts. As you build up your experience with these charts, eventually you're going to start navigating with them and flying off on your own to some great adventures. So look forward to that day. In the meantime, study hard, be well, and we'll see you next time.